Science at SHS is about tapping into children's innate sense of curiosity. Why do things happen in the way that they do? Learning and teaching in science embraces this idea of a shared journey of discovery between the pupils and teachers. Our most important resource is our staff. The science team consists of 22 dedicated, knowledgeable and passionate teachers from a diverse range of backgrounds and experiences who have one thing in common. They want to deliver learning experiences that unlock the natural curiosity and allow pupils to flourish and realise their potential in science. We emphasise that journey of discovery through practical activity and have a first-class technician team to offer and deliver that practical support. Even during the current restrictions, we are still offering practical opportunities to our pupils, particularly at GCSE and A-level. We have 13 well-resourced laboratories. Our teachers are innovative and embrace evidence-based practice in their teaching. Retrieval practice is used extensively in lessons, and the team keep up to date with the latest cognitive science to ensure all pupils in their classes make optimum progress.
In A-level chemistry, you're basically doing an extension of the GCSE. So a lot of the topics you study will at least begin with a recap of what you've done at GCSE, and then you'll go on to study it in more depth. So for example, when we do bonding, we'll still cover the types of bonding you do at GCSE, but you will also then look at intermolecular forces and the types of forces there are, which is something you don't get to cover at GCSE. So it'll be a lot of similar content, but in more depth than you will have studied it before. It's split into three broad strands. So we've got physical chemistry, which covers rates of reaction, energetics, kinetics, how fast reactions go, and some acids and bases as well. You've then got organic chemistry, which is everything to do with carbon. So the types of molecules we have, how they react, the mechanisms that show how reactions are happening as well. And then we have inorganic chemistry, which looks at the bonding and structure of metals and also trends in our periodic table. There's a slight difference between A-level and GCSE. Although you do have required practicals still at A-level, these are now assessed. So in each practical, you might be assessed on a number of different competencies to do with how you approach the practical, how you plan, your ability to work safely in the lab, and how you can research as well. As you do the practicals, you'll get given a pass or fail for each of those competencies. And then at the end of your course, this is just recorded alongside your grade, again, as either a pass or fail on that. On the practicals. There's 12 of them that you cover across those strands, physical, organic and inorganic, so they'll be covered on both sides of your teaching. And unlike GCSE, you have to keep a record of all of these. So you'll get a lab book where you can record all of the information about your practicals, and again, they could ask you about those in your exam as well. Step up from GCSE to A-level, I think the biggest step up would be in the maths requirement. At GCSE there is a significant maths requirement that gets bigger at A-level, and actually the majority of the physical side of A-level is based on maths. So we really recommend, if you're thinking about doing A-level chemistry, to also consider a maths option along with that as well. It's just going to help you with that regular maths practice. But if you don't choose maths, that won't stop you from doing chemistry. We will still do lots of practice in lessons. As we said, the step up in practicals is very different. At GCSE, you did required practicals, but you just got asked about them in the test. There was no kind of assessment of your practical ability. At A-level, you will be assessed on your ability to do practicals. And this is important because if you want to go on to do a science at university, they want to know that you can actually carry out the practicals that you need to do. So for each of those practicals, you'll be assessed on how well you can do each of those competencies so that your universities know that you're able to work safely in their labs. Other than that, you're really just studying the GCSE topics in more depth, but the way that you study, you'll be more independent. So you might not get set as many specific homeworks. You might have to self-allocate your time to decide what topics you need to focus on, what areas you need to study in more depth. And as well in your practicals, you'll have a lot more independence. So your teacher is less likely to tell you you're doing that bit wrong. They'll let you get it wrong, see the mistake and try it again. So you may find that to be slightly different, but actually that's a really good way to learn. And making those mistakes at A-level, I think actually helps you get even better in doing those practicals. To me, the thing that makes chemistry for us is the people we've got in our department. We've got a huge range of experience And most of the people teaching you have actually worked in jobs to do with chemistry prior to teaching. They might have worked in labs, or they might have worked with different companies on research. So we've got a huge range of experience, and if it's something that you're interested in, they can provide you with so much information about how chemistry can be used in the real world, what you could go on to do with it, both at university and in later life. And I think they really bring that enthusiasm for chemistry into the department, into your lessons, and show you how interesting it can be.
I love science because we have a myriad of problems facing humanity, and science can solve those problems. And I am a passionate science teacher and leader of science education because I really want to equip the next generation to be able to solve those big problems like climate change, like world pandemics. And I believe that at Surbiton we can really achieve this and send a huge army of STEM specialists out to help solve those problems.